Characteristics of radical functions are different aspects of what this function looks like. For example, your generic parent graph is this one right here, where we have y equals the square root of x, and you can see a sketch that we've talked about before. This is your generic kind of what else is going to happen to this graph. And so things that we want to remember are, for example, your a value. This a value is going to stretch or shrink. Right? So it's not going to do any kind of shifting, but it's going to make this graph either go down or it's going to stretch up. Right? And we've seen that before in other graphs, for example, the trig functions. Other things are that if your a value is negative, this is when we reflected about the x-axis. And so that's where this whole graph would flip around the x-axis. And again, we'll see that because when this value is negative and we perform order of operations on our parent graph, it's going to change all of these to negative values. The other aspect is right here underneath the radical itself. All right. So little things about this is that when you take x minus h and you set it equal to 0, this is going to give you your horizontal shift, or we call it a horizontal translation. All right. And so that's going to say, how are we going to go left or right? And the other thing is that if your x value is negative, so that means the coefficient here on the x. Sometimes what we'll do is we'll put another variable there, like a little variable b. All right? And so what we'll say is instead of x, we'll say, what if the coefficient or the b value is negative? Then what that means is that we're going to reflect about the y. All right? And so it's going to take this whole graph, it's going to flip it up over to the other side. It's going to that way. The last little thing is this plus k, so anything that's being added to the radical. All right, this is going to be your vertical translation. And so this is how you're going to shift up or down. All right. So taking all of your values and going up or down, just again like we did when we had our other functions like trig. So little characteristics that we need to remember other than that would be, how do you find the point of origin? All right. So the point of origin, in your parent graph, it always starts off with 0, 0, and that's your coordinate. However, when you try to change this, so we have more going on now, this x value is going to change to be whatever happens when your x minus h is set equal to 0. Now again, we really want to think about our radicand being set equal to 0. So that way if we have coefficients attached to the x, we also consider those. So it has to be everything. So again, I put a little b up here before. You can think about it the same way as add that on there. So anything that's underneath the radical. And then my y coordinate will change to be whatever the k value is. Right? And you'll see that happening. All right, so you're going to start off with the point of origin being 0, 0, and then that's going to change as we change those two components. Then we have our domain. Right? And we've talked about our domain before, but again, it starts off with going from 0 to this case infinity. Right? And so when you set your radicand to be greater than or equal to 0, that's going to change what this domain looks like. Right? Now your range. Your range is all of the y values that are used when you start graphing. So in this case, your range, the lowest y value here is 0, and then it's moving in a positive direction. So right now, our range is going from 0 to infinity. And this is going to change as we deal with the a's and the k's. So as a generic form, if your a is positive, all right, then your range is going to end up being starting from k and going to infinity. All right. If your a value is negative, all right, then what happened is that your graph is then going to flip about this way, and it's going to change your range to go from negative infinity up to k. So it's going to flip my range, and that's really important. So we have to now consider what happens with the a value when we're dealing with the range. Right. Now we also have something called our end behavior. All right, and so your end behavior is saying what's happening to the two ends of the graph. All right. And so the way that we talk about that is we say what is happening as x is approaching negative infinity, and what happens as x is approaching positive infinity. All right, so as x is approaching negative infinity, what you're saying is that your x values are getting smaller. All right, they're getting smaller, and what happens is that your y's are approaching 0. All right, so if I pick x values and I start plotting them, your x values are going to keep going down this, your y values, and eventually you're going to get to 0. All right, you're not going to get any further than that. Now, as your x values get bigger, right, and so saying that x values are getting larger, that's how you approach positive infinity. So x values are getting larger, this y value is going to keep going up towards infinity. And again, those are going to change depending on what happens with my a and my k value. All right, so you want to just think about as x is getting smaller, what is the y value that you're tending towards, and as x is getting bigger, what's the y value? Right. Now the last two characteristics are about your intercepts. All right. And these are places where the graph crosses the x and the y axis. So your x-intercept. Right. Right now in your parent graph, your x and your y-intercept are both 0, 0. However, those are going to change as we start manipulating the function. So to find your x-intercept, you're going to substitute the y variable to be 0 and solve for x. Right. Now the thing is, when you do this, you must check to make sure that you actually get a valid value. Same thing with the y-intercept. Right. Now what you're going to do is you're going to substitute everywhere there's an x, you're going to put a 0, right, and you're going to solve for y. Right. Now you're going to see sometimes you're going to solve for an x or a y, but when you plug them back into the original function, you're going to get something that does not make sense. And when that happens, then you're just going to say there is none. But if you get a valid value and you plug it in and it still works, then you're good to go. So these are some of your characteristics of radicals. And so now we're going to do some graphing.